Norman. I'm Juan.
I'm James. And
we are
making
FerroFluid
Experiment.
We're going to determine the magnetic effectiveness of ferrofluid using different ionic compounds containing magnetic metals.
The three metals we're going to be using is cobalt, iron, and nickel. So magnetic.
Our control group is going to be the iron, which is originally the ferrofluid, and the two experimental groups will be the cobalt and the nickel solutions.
a magnetite that's suspended in a colloid, and it responds to magnetic fields.
So this is the production of ferrous chloride. This is the product that we need in order to get the ferrous chloride in order to react with it. In the end, the final solution would be ferrous chloride with ferric chloride in order to create a magnetite. It's called ferrofluid. And as you see here, the iron from the ferric chloride is being reduced to become, this is +3. It's reducing to become Fe +2.
Okay, so here we have the equation for the formation of ferrofluid itself, which is basically what we're doing is we're titrating ferric chloride with ferrous chloride and ammonia with excess water added in order to result in ferrous oxide with ammonium chloride. And so basically we have a charge of +3 on ferric chloride and +2 on ferrous chloride. And also we have a charge of +2 on ferrous oxide. Basically what that means here is that what we're doing is we're actually reducing the iron here, and this one contains the same charge, but what we're doing is reducing it so that this is the same charge of +2 by gaining an electron, and by gaining that it becomes magnetic. And so what we're doing that is we're producing our magnetite, which is what this compound is right here.
And this is also a complex ion, which has a charge of -2. Yeah. So when our reaction is going to be completed, we're going to use neodymium magnets to draw away the magnetite from the excess water from here.
Which one is the anode?
Alright, so here we are cutting some steel wool in order to mix it. What we're looking for here basically is some bright green color after we mix it with the PCB etchant, because we should be, as a result, get FeCl2.
Basically what's happening when that happens is FeCl3 is being reduced. Yeah.
It is being
reduced to Fe.
Here's some past the stirring rod. Where's our stirring rod? Can you bring it, please? I already did.
See, there it is.
That's much better.
As you can see, the solution is quickly changing colors to light green.
Basically, here we are. We're filtering out the iron fillings from our PCB etchant, which our ferric chloride is, and we're just currently using a filter paper so we can get into its just the liquid alone. And right after that, we're gonna add some more PCB etchant. We're gonna add some iron. We're gonna add some ammonia, and we're gonna see how that goes. And we're gonna stir it up and try and make some ferrofluid.
We're titrating
Richard, don't lean
our solution with some MH3 ammonia.
What we're expecting to see here is that black precipitin that we're looking at, and that should be the basis for our magnetite in order to form our solution. I do see some brown stuff at the bottom. I wonder if we can, that's going to get titrated. Is that going to get turned? Well, no.
How much time have we spent here? Like 2 minutes?
3 minutes.
3?
I say 3. We're about to hit 50. So I'll slow this down.
All right.
Not bad.
Said over 3 to 5, 10 minutes.
Yeah. No, he said to stir it for 5 minutes.
Yeah, but what about the thing?
Cool.
Way to smell it, one.
I guess
delicious.
Actually, yeah.
Where do we get gloves?
Hot? You mean the hot hands?
Just any
Gloves and gloves. That's okay. Because we need to take the magnet out without really touching it.
Alright, go find out. Yeah, you see the water layer now? There's actually a layer of water right there. Richard, do you see it?
I don't think it's water.
Yeah,
It's NH4. I mean,
it might be NH4.
We are adding a lay gas into our current ferrofluid solution. Gonna add about 1 to 2 milliliters, and apparently I can't use a pipette to save my life.
So we're doing this to liquefy it and
We're doing this
suspend the particles.
Yeah, we're doing this basically to suspend all the particles within the ferrofluid.
and creating a colloid, whatever it's called.
So here we have our solution of nickel chloride, and we're about to mix some PCB etchant in there. Ferrochloride, and we're going to see how this goes for right now. So we're going to get it stirred up a bit, and we're now going to start adding our ammonia. James over there is eating some chips. So, alright, let's get the drip started. Yeah, it's going to spread. No, keep it going, keep it going. Let it drip a little more freely than that, yeah. Have it about like that. No. Drip a little faster. You need any help on that? No. So as you can see, we have a precipitant forming. Right now we don't know whether it's actually magnetite or not.
So here we are titrating the cobalt Cl2 solution with the FeCl3, so we can get
ammonia.
And ammonia. That's what's being titrated right now in the pipette. And we are actually getting some precipitate, so it's a good sign.
We're going to see if actually this has any magnetism in it, if it produces magnetites at all or not. We'll figure out in a few minutes once we finish titrating.
Okay, so this is one of our experimental tests. We're trying to see if nickel would also work in replacing the iron. So we titrated nickel chloride inside with ammonia, and as you can see, it's not magnetic. There's no sort of response to the magnet. So
Alright, so here we have is cobalt chloride with ferric chloride as well in an HCl solution mixed with ammonia. And as you can see, after titrating it, we didn't get the characteristic black powder that we were expecting, and neither is the solution at all magnetic. It doesn't actually respond to the magnet at all in any way. So the solution is not ferrofluid in any way.
and this solution is the same as that, except it's with nickel this time. Okay. The nickel, obviously it didn't react very well with the ferric chloride, and again, there's no sort of magnetism, there's no response to the magnetic fields.
And this is our final product, and this is the actual ferrofluid, and there's iron inside. And as you can see, it responds to the magnet, which means it works.
Okay, and here we'll just give you a close-up how this works. Putting the magnet close to it, it's making this shape. I can bring it up here, start raising it up the side. And same thing with this one.
Alright, so here we have our ferrofluid that's actually working, and what we're going to do is we're going to place a magnet, and we're going to show the effects of a magnet under it. So I already got one under it, James. So here, I got James. So as you can see, by putting the magnet under it, you get the ferrofluid actually responding to it, and it's actually moving along rather nicely here. As you can see, if I lift the magnet off, it returns to its normal shape, like a complete liquid. The moment I put it on it, all the magnetite within it clumps together, it forms the shape of the magnet that is actually beneath it. And the same.
Hi, I'm Richard.
I'm Norman. I'm Juan.
I'm James.
What?
And
I thought we started from the beginning.
I'm Richard.
I'm Norman. I'm Juan.
I'm James.
And
we are making
FerroFluid? Today we're gonna check how